Hello, welcome everyone to question number 9, flattening a linked list. The topic linked list in Geek for Geeks must to do coding interview questions. Have a quick look at the question and we will be discussing the meaning and approach behind. Before that, if you have any extra email IDs, please do subscribe and support our channel. And if you have any doubts, leave a comment down below where we will be very quick to respond. Now coming to this question, as you can see, we have been given a multiple linked list which are merged together in the input, and we have to convert them into a single line of linked list. That will be this line. Okay, we have converted into a single line linked list. That will be our output. Now the question comes, how can we convert this? Okay, so we will understand that what we're going to do is we're going to iterate this dot next elements. These are dot next and this is dot bottom elements. This bottom and this is dot next element. So what we're going to do is we're going to iterate dot next elements. Okay, after iterating this dot next element, we'll go to the last element and check the dot next is none or not. If it is none, then we're going to store this element, okay, separately. That will be 28, 35, 40, 45. Okay, and we're going to use the recursion approach in this similar manner. So, and we're also going to take the previous dot next and its linked list using dot mode bottom. Now we got two linked list here. Okay, now we got two linked list. Let us name this as A and let us name this as B, and we're going to use one dummy pointer. Let us call it as temp. This will be our dummy pointer node. This will be our dummy pointer. Fine. Now what we're going to do is we're going to compare A and B. Okay, while we compare, we will be storing the smaller element under temp dot bottom. We'll be storing that in temp dot bottom, and we will reassign that temp dot bottom to the linked list that we are going to have. Okay, now let us start one by one. Here we're going to compare 19 is smaller than 100. Yes, it is smaller. So now temp, whatever it is pointing, doesn't matter. Now we are saying the smaller element, the temp dot bottom, this is dot bottom, so that should point towards the smallest element. Okay, fine. After that, we'll also move A to the next element. Now A will be at this point, A dot bottom. Okay, this will be A dot bottom. That will be reinitialized as A. Then we'll be having A is 22. Now we're going to compare this again with B. 22 is smaller than 28. Yes, if it is smaller, then we are going to store that 28 in the temporary variable. After that, we're going to move A to the next element and we're going to compare again. Is A smaller than B? No, it is not smaller. So we're going to store this 28 under the temp node here. 28 has come, and we're going to move the B element also to the next pointer. This is our next pointer, right? Now B is at 35 and 80 is going to compare again with the A that we have. Is A smaller than B? No, it is not. So we're going to store B element here, and we're going to move one place ahead. Is 40 smaller than 50? Yes, we're going to store B element here again because A is greater. So we're not going to store that. Whatever smaller, that should come first. Okay, 40 has been given. And again 45, next element we will be moving here. We will check 45 smaller than 50. Yes, 45 will be coming. Since the next element is nothing, now whatever elements are remaining in other list, we're going to store them. Okay, now we got this list 19, 22, 28, 35, 4. Now what we're going to do is we will say the new root will be 19. Okay, we will be assigning this 19. And when we assign this like this, our new list will start from 19, 22, 28. This will be there. Okay, now this 28, 35 will not be here. The newly sorted list will continue from this point. Okay, similarly, now this list is given. After that list, where we will say the dot next element is none. Yes, it is none because we have sorted out the list from the right side. Now there is no list in the right side. Okay, so similarly we will take the last element list here, that will be the sorted one, and the previous one, that will be 10 and 20. Okay, now the same method that we have applied, it will apply to the this list also. Okay, and it will happen recursively one by one. Okay, in that way we will be getting the output 5, 7, 8, 10, 19, 20. I hope you have understood the approach. If you haven't understood the approach, let's go into the coding section. Now we are inside the Geek for Geeks website here, and as you can see, we are going to use the right recursion approach. We're going to take the rightmost two elements Okay, and we're going to rearrange that list and going to reassign that. Okay, now we can see we have a flatten function. Inside that we have taken merge two lists AB. This function will compare A, B elements, and whatever the smaller element is, that will be stored under temporary variable node. Okay, in this way we will get one list which is in a sorted manner. Okay, and after that is completed, we're going to return that first address. Okay, first address of the temp will be rest.bottom, and we're going to return this, and it will be our new root of the previous element. Okay, after this function is for merging two linked lists as we have discussed in the presentation. After that there is a condition, if root equal to none, root dot next will be equal to none, and we will be returning root. This will be used for recursion. Okay, this merge function is just only comparing two linked lists and merging them, but this flatten function that you can see, this is used for recursion. It will call the elements one by one. This flatten will call the elements one by one, starting from the right side. And if you imagine that if you're using this flatten root dot next, it will call it the function itself again and again till we get the last element. You can see if root equal to none, root dot next equal to none. This root dot next equal can only happen when we have a single element at the last. Okay, and in that single element you can see we have 28 here. We have 28 here that is being called. Okay, that is being called and being stored here. Okay, and that will become our root dot next. And after calling that function, we got the 28 as the root of that list. Okay, we're going to store that in root dot next, and the function called, right, the function has been called in the previous function. So in the previous function the root will be 19. Okay, root dot next is 28, then the root in that previously called function will be 19. So the root will be here 19 and root dot next will be 28. Okay, now this is being called to the merge to list function. This will rearrange the functions and we will get one address which has been sorted. Okay, and we will be reconnecting that as the root. Okay, root will be equal to 19, then whatever the elements are there, 19, 22, 28, 35, that will be sorted. We will get that as a new root, and we'll be returning this root to the previously called function, and it will repeat itself like that till we reach the one linked list. Okay, till we reach one linked list it will repeat itself. Okay, and finally when all the elements have been compared, we will get this output 5, 7, 8, 10, 19. I hope you have understood the code and also the meaning and approach behind it. If you haven't understood, just leave a comment down below. We will try to explain it more clearly if we have any problem. But if you understand, please give us a like, and also don't forget to subscribe our channel. If you have any doubt, just leave a comment down below. We will be very quick to respond. Thank you for watching till the end. Let's meet in another question.